Hello everyone, good afternoon. I am Vikas Kumar, Assistant Professor of Mathematics, IIMT College of Science and Technology, Greater Noida. Today, I am delivering a lecture on bisection method. The contents for this lecture are introduction, bisection method, the main concern when we use these methods, one example, advantage and disadvantage of bisection method. Introduction. As we are using digital computers widely, so we need numerical methods to solve various problems. For this session, I am taking bisection method for discussion. This method is also known as method of successive bisections. In this method, we successively halves the interval to get a result of desired accuracy. The main concern when we use numerical methods or bisection method is error and accuracy. Means error involved in the solution should be least. Computational ease, it should be easily implemented. Time involved in getting the solution and the rate of convergence of method, that means at which speed the solution we get using these methods. So these were few concerns when we use these methods. Bisection method, the main topic for this lecture is the bisection method. As I earlier told, this is interval halving method in which we repeatedly halves the interval to get the solution of an equation. Equation may be algebraic or it can be transcendental. This method involves few following steps. Let we have a function fx is equal to 0 and we want to find the root of that equation. Then in first step, we have to decide an initial interval. So we will start to choose an interval AB such that in that interval function has opposite signs at endpoints, meaning FA into FB is less than 0. That means if the function is positive at one end of interval, then it should be negative on other end. Then we will go to step number 2. We will calculate the mid value. This is the formula of bisection method. We will get a point C. C is equal to A plus B upon 2. After getting this C, we will evaluate the functional value at this point C. This is step number 3. After getting this point C, we will get 3 points A, B and C in interval AB. By these 3 points, our interval become half, two intervals of half of width of previous interval. This way, we will have two intervals, A to C and C to B. After that, we will examine for these two new intervals if FA into FC is less than 0 or FB into FC is less than 0. If the first condition satisfied, then we will say root lies between the interval A and C. And if second condition satisfied, we will say the root lies between the interval C to B. Then we will repeat step number 2 to 4 until interval become sufficiently small or achieve the predetermined accuracy. So, as I told in last slide, at each step we make half of interval. This way, when we repeat this process repeatedly n times, after n step, we will get a sequence of intervals. I have written in 1, 2, 3, 4 and in n. Lastly, we will get a very small interval an and bn. Also, when we will taking interval AB, the first approximation we get is x1. After making this interval small by half, the interval become A1, B1 and the second approximation to root becomes x2. This way, we will get a sequence of smaller and smaller intervals as well as we get a sequence of approximated roots. That is x1, x2, x3 and x1. This way, interval becomes smaller and smaller and roots become accurate and more accurate. This is a graphical representation of first approximation. We have taken an interval AB. In this interval, the functional value is positive at one end and negative on other end. We apply the formula for getting C first approximation. So this way we will get 3 points A, B and C. By these 3 points, we will get two intervals A to C and C to B of half width. When we repeat this process, graphically we notice that at each step the interval become smaller. Here, when we apply more approximation, that is first iteration, second iteration and third iteration, we will notice the interval become smaller and smaller, and our solution or approximated solution become closer to the exact root. Error involved in this process. When we repeat this process n times, the interval will be an and bn. The width of this interval is bn minus an, and which is equal to b minus a divided by 2 raised to powers n. That means when we apply this method n times, the error becomes very smaller. So the we can say the error after n steps is b minus a divided by 2 raised to powers n plus 1. Here is one example how we solve a problem using this bisection method. Here question says, using bisection method, find the root of function 2x cube plus 3x square minus 12x minus 6 is equal to 0. And we are asked to find the root of this equation in the interval minus 1 to 0 using in 4 approximations. So to solve this, we calculated the functional value at the point minus 1 and 0, that is the end points of interval, which are 7, which is positive, and minus 6, which is negative. So by these two, we notice that the FA into FB, that is F at minus 1 and F at 0 is minus, here I wrote minus 6, but it should be minus 42, which is less than 0. So we evaluate the center of interval, we will apply the formula and we will get this minus 0.5 x1, first approximated value for the root. We will find the functional value at this point. We notice that the functional value is 0.5, which is positive. So we will replace our interval AB by x1b. Here I explained in some different way how we will replacing AB by x1b. Now our interval becomes minus 5 to 0, and we will approximate for the second approximation, which is minus 0.5 plus 0 divided by 2, that is minus 0.25. And we will calculate the functional value at this point, which is minus 0.25, is minus 2.84375, which is less than 0. As I earlier told, the functional value should be opposite at the end of intervals. So this way we have a new interval minus 0.5 to minus 0.25, in which the function is changing the sign. So the root lies between this interval. After having this interval, we get minus 0.375, and the functional value at this new approximated root is again minus 1.183597375, which is less than 0. So again we will refine the previous interval. So now the new interval in which function is changing sign is minus 0.5 to minus 0.375. This way, when we will apply this method again, we will get the new root is minus 0.4375, and the functional value at this new approximated root is minus 0.343261717875, which is less than 0. So again, we will choose a interval in which function is changing sign. So we will get a new interval is minus 0.5 to minus 4375. We applied this method 4 times. So the approximated value of root is minus 46875, and the error involved after these 4 steps is 1 upon 32, that is 0.03125. Here the advantage and disadvantage of using this method. The bisection method is always convergent. It is an advantage of bisection method, and the rate of convergence is very slow. This is the disadvantage of using bisection method. So that's all for this lecture. Thank you.